Hello, hi. Welcome to Carbon Chemistry channel. My name is Venkat, MSc Chemistry from Andhra University. So many of my friends and students are requested me to start a channel in which more explanation and neat ball work is there. I thought of that I will start a channel. So finally I started a channel. Please support me. If you like my videos, please subscribe, share and like. Coming to the point, in this channel I am going to explain chemistry in detail, in which the mode of explanation and the path of explanation is, first of all we will see the concepts of chemistry in detail. According to that we will see some objective questions. End of the chapter we are going to see some previous year NEET questions, IIT questions, if it is possible CSAR gate questions also. We are going to start hybridization concept. It's a basic chemistry concept. It is useful for both NEET and IIT. For the hybridization concept, we need to learn VBT, whisper theory, and molecular orbital theory in detail. So it takes too much of time when you compare all these theories while doing objective questions. So I have a shortcut method for you. If you follow my class, we can do the hybridization and we can predict the geometry of the molecule in a fraction of seconds. Till the end, if you like, subscribe and share. And I don't want to waste your time and I don't want to repeat the subscribe share in every video. This is the first video, that's why I request you. Please support my channel. Right. Coming to the point, hybridization. Hybridization. So hybridization is simply we can say mixing of orbitals. Mixing of orbitals. Mixing of orbitals is called hybridization. It's called hybridization. Mixing of orbital is called hybridization. So what are the orbitals we have? We have S, P, D and F orbitals. Right, mixing of orbitals is called hybridization. What are the types of orbitals we have? S, P, D and F orbitals we have in chemistry. So how could these orbitals are going to mix? If S is mixed with P, we have sp hybridization, sp2 hybridization, sp3 hybridizations are possible. If S and P and D mix, then we have sp3 hybridization, sp3 d2 hybridization, sp3 d3 hybridization. Right? Yes, P, D and F combination is also possible, but that concept is not in your level, that you will learn in MSc and graduate masters post graduation level. So coming to the point, S can mix with P in to form SP, SP2, SP3 hybridizations. SPD can form SP3D, SP3D2, SP3D, D3 hybridizations are possible. Now we'll see the shortcut methods of hybridization. Means here the one point we should remember, hybridization number is equal to number of sigma bonds plus number of lone pairs. So you should remember, I written here lone pairs means two electrons. If hybridization number is 2, hybridization number is 2, then sp hybridization. If it is 3, sp2 hybridization. If it is 4, sp3 hybridization. If hybridization number is 5, sp3 dehybridization. If 6, sp3 d2 hybridization. If it is 7, sp3 d3 hybridization. So these are the hybridization number. The point is how to calculate hybridization number. I will explain you. Before going to calculate hybridization number, we should know what are the possible geometries. What are the possible geometries along with the combinations of lone pairs of electrons. So first of all, just write down. I will give you one table in which all the geometries hybridizations with possible lone pairs are also there. First one I can write it is hybridization, hybridization, number of lone pairs, and geometry, number of lone pairs and geometry. If sp hybridization, zero lone pairs, geometry is linear. Geometry is linear. The shape you can write it as in this way. So linear, 180 degrees. 180 degrees. sp2 hybridization, zero lone pairs. The shape of the molecule is trigonal planar. Trigonal planar. The shape of the molecule is trigonal planar. One more combination is possible in sp2. If sp2 hybridization, one lone pair of electron, the shape of molecule is V shape, or we can say bent structure. Bent structure. What is in the bent structure means one of the vertex of trigonal planar is occupied by one pair of electrons. That's what we call lone pair of electrons. So these are the bonded pairs. One lone pair is occupied. sp3 hybridization is zero lone pair of electrons. The basic structure is tetrahedral. Basic structure is tetrahedral. Tetrahedral geometry, which looks like tetrahedral geometry. sp3 hybridization with two lone pairs. So two vertex of the basic tetrahedral structure is occupied by two lone pairs of electron. The structure becomes V-shaped molecule, or we can write bent structure also. Bent structure. So molecule geometry seems to be like two lone pairs of electrons. Next hybridization is sp3d, zero lone pairs. The basic structure of sp3d zero lone pair is trigonal bipyramidal. Trigonal bipyramidal. Trigonal bipyramidal. The geometry looks like trigonal. This is trigonal bipyramidal. Trigonal bipyramidal. Next combination is sp3d one lone pair. One of the vertex of trigonal bipyramidal is occupied by one pair of electrons. That's called lone pair of electrons. This lone pair is occupied one of the vertex of trigonal bipyramidal. So the geometry is very important. Seesaw model. This model of hybridization is important, and so many times it was asked in previous year, I mean NEET and IIT exams. So the structure look like one of the vertex is occupied by the lone pair. So it is looks like this. T-shaped molecule. The structure looks like two lone pairs are occupied. sp3 D, three lone pairs. So three vertex of trigonal bipyramidal is occupied by three lone pairs of electrons. Structure is linear structure. So molecules looks like one lone pair of electrons, two lone pairs of electrons, and three lone pairs of electrons. sp3 D2, zero lone pairs. Basic structure of sp3 D2. Why I am telling basic structure is there is a no lone pairs are present. There is no lone pair repulsions are present. So basic structure is octahedral geometry. Octahedral. What is the geometry of octahedral is octahedral geometry. Octahedral. This is four faces, four faces, and two faces and another two. So eight faces. Octahedral geometry. sp3d2, one lone pair of electron. One of the vertex is replaced by one lone pair of electron. Then the structure becomes square pyramidal. Square pyramidal. The structures look like square pyramid. Actually, no tractions. Square base, it looks like a pyramid. sp3d2, two lone pair of electrons. Geometry is square planar. Geometry is square planar. The structure looks like this look like a square planar. The next hybridization is sp3d3, zero lone pairs. The basic structure of sp3d3 with zero lone pair is pentagonal bipyramidal. Pentagonal bipyramidal. The structure is pentagonal. This is pentagon. Pentagonal bipyramidal. Pentagonal bipyramidal. sp3 d3, one lone pair. This is pentagonal monopyramidal. Pentagonal monopyramidal. Its geometry looks like one of the vertex is occupied by lone pair of electrons. Just remember all these combinations, just the table. Now I will tell you how to calculate hybridization number. Based on that hybridization number, how can we get to know, how can we predict the structure geometry of the molecule? Simple examples. Take for example XeF2 molecule. XeF2 molecule. First of all, what should we do means we need to identify the central atom. Central atom. Generally, central atom has no electron negativity. So just identify the element which is having less electron activity, that most of the cases act as a central atom. So next one, take the number of valency electrons of the central atom. Here central atom is xenon. Xenon is present in the 8th group in a modern periodic table, 18th, that 8th A group. So it has 8 valency electrons, 8 valency electrons, 4, 5, 6, 7, 8. 8 valency electrons. So each electron of xenon can have a chance to form a bond with, suppose, fluorine. So here two fluorine atoms are there. One electron can form bond with one fluorine. Another electron can form bond with another fluorine. So these two electrons are act as a one lone pair. These two electrons are act as another lone pair. These two electrons are act as a one lone pair. As I said, lone pair of electrons means two electrons should act as a one pair. Lone pairs are present. So what is the hybridization number? Hybridization number is equal to number of sigma bonds means 2 sigma bonds plus 3 lone pairs of electrons. 3 lone pairs. So hybridization number is 5. If hybridization number is 5, what is the hybridization? Hybridization number is 5. Then hybridization is sp3. 5 is there, so sp3d. sp3d. So sp3d, how many lone pairs are there? 3 lone pairs. sp3d, 3 lone pairs. What is the geometry? Linear geometry. Linear geometry. One more example. Take another example. XeOF2. What is the central metal? Xe. 8 electrons are there. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen always form double bonds. So it requires 2 electrons to form double bond. And one fluorine atom, one bond. Another fluorine atom, another bond. So these 2 electrons are act as one lone pair. And these 2 electrons are act as a one lone pair. So how many sigma bonds? Out of the double bond, one is sigma bond, another one is pi bond. So one sigma bond from oxygen, another sigma bond, another sigma bond. So total 3 sigma bonds are there, comma. How many lone pairs? 2 lone pairs are there. 2 lone pairs. So hybridization number is equal to 2 sigma bonds plus, 3 sigma bonds plus 2 lone pairs. So total 5. If hybridization number is 5, then what is the hybridization? sp3d. How many lone pairs are present? 2 lone pairs are present. So sp3d, 2 lone pairs. What is the geometry? sp3d means the basic structure is trigonal bipyramidal geometry and 2 lone pairs are there. So it will become T-shaped molecule. T-shaped molecule. T-shaped molecule. But we see some other tough examples. We'll see some tough examples in which negative charge is present or positive charge is present of the molecules. If negative charge is present, if negative charge is present on the molecule, we need to add electrons. add electrons. While doing hybridization number, while calculating hybridization number. If suppose molecule, if positive charge is present, if positive charge is present on the molecule, so we should remove the electrons. We need to remove electrons. I will tell you one example for this. For an example, HCOF5 having negative charge. So here we should remember one point. We need to add electrons as many as the negative charges present on the molecule. Here one negative charge is present, add one electron during the calculation of hybridization number. How? I will tell. Xenon is a central metal atom. How many valence electrons are present in xenon? 1, 2, 3, 4, 5, 6, 7, 8. One negative charge is there, so add. This is extra added electron. So oxygen is there. Oxygen forms double bond, so 2 electrons for the oxygen. 5 fluorine atoms. 1 fluorine, second fluorine, third one, fourth one, and fifth one. So the electron which is from the xenon and one we added, so act as one lone pair of electron. So how many sigma bond? This is one sigma bond, another one is pi bond. So both are not sigma bonds. So we should take only one sigma bond. Remaining 5 are sigma bonds. So total 6 sigma bonds and one lone pair of electron. So hybridization number is 6 plus 1, 7. 7 is hybridization number. If hybridization number is 7, then what is the geometry? sp3d3. sp3d3, how many lone pairs are there? One lone pair. So sp3d3, one lone pair. What is the geometry? Pentagonal monopyramidal. So this is the way to calculate hybridization number if the molecules bears a negative charge. I will explain you one molecule which is having positive charge. Take for example NH4 plus molecule. Here central metal atom is nitrogen. What is the group number of nitrogen? Fifth group. So group number itself nothing but valence electrons. So 1, 2, 3, 4, 5. And plus is there. So we need to remove this electron. As I said, if plus is there, we need to remove the electron. So remove this electron. Then how many electrons we have? 4 electrons we have. How many hydrogens are? 4 hydrogens we have. So 1 hydrogen, another hydrogen, another hydrogen, another hydrogen. So these 4 are sigma bonds. No 4 sigma bonds. There is no lone pair. So hybridization number is 4. If hybridization number is 4, basic geometry sp3. S43 molecule. What is central atom? Yes. S group number is sulfur group number is 6. Take 6 electrons. 1, 2, 3, 4, 5 and 6. 3 oxygen atoms. So 1 oxygen atom, 1 oxygen atom, 1 oxygen atom. So 3 double bonds these are. Out of 2, one is sigma, another one is pi. One is sigma bond, another one is pi bond. One is sigma bond, another one is pi bond. So total number of sigma bonds are 3 sigma bonds. There is a no lone pairs. So hybridization number is 3. Hybridization is sp2, 0 lone pairs. Trigonal planar structure. Take SF4 molecule. Again sulfur is 6th group element. 1, 2, 3, 4, 5, 6th group. 4 fluorine atoms. 1, 2, 3, 4. 2 electrons are lone pair. So 4 sigma bond plus 1 lone pair of electron. So hybridization number is 5. Hybridization is sp3d, which one lone pair. sp3d with one lone pair. What is the geometry? I told you important model. Seesaw model. Seesaw model. Sometimes we have the molecules with similar atoms. Similar atoms in the sense I3 plus. Some cases we have molecules are I3 plus. So one of the I act as a central atom, remaining two are bonded atoms. So one I, what is the group number of I? 7th group. So 7 valence electrons, 3, 4, 5, 6, 7. Plus is there as per our rules. If plus is there, we need to remove an electron. 1 plus should remove 1 electron. So remaining one I can form one sigma bond, another I can form another sigma bond. So these two are act as one lone pair, these two are act as another lone pair. So two sigma bonds, comma, two lone pairs. Two sigma bonds, comma, two lone pairs. Now hybridization number is 2 plus 2, 4. If hybridization number is 4, then hybrid geometry is sp3. sp3 with two lone pairs. sp3 hybridization with two lone pairs. V-shaped molecule or bent structure. The same way we have water molecule. So in water molecule, what is the central atom? Here, oxygen acts as a central metal. Oxygen group is, what is the group number of oxygen? 6. 1, 2, 3, 4, 5, 6. So out of these 6, one hydrogen. These two are act as a one lone pair. These two are act as another lone pair. Two sigma bonds, comma, two lone pairs. So that's why hybridization number is 2 sigma plus 2 lone pairs. So 4. Hybridization is sp3 with 2 lone pairs. V-shaped molecule. This is water. 2 lone pairs are present on oxygen. Take one simple question. Hybridization of solid BeCl2. So question is the previous year question. Options are A, Sp, B, Sp2, C, Sp3, D, Sp3, D2. So by looking at the molecule only using our shortcut method, Be is a second group elements 1, 2, 2 chlorine atoms. So 2 sigma bonds plus 0 lone pairs. So hybridization 0 lone pairs. Hybridization number is 2. Hybridization is Sp. So Sp hybridization 0 lone pairs linear geometry, but it is wrong. Why means they said solid BeCl2. BeCl2 in solid state has polymeric structure. So the existence of BeCl2 in this way. So it continue like this. Polymeric BeCl2. So if you looking at the particularly Be atom, how many atoms surrounded the Be? 4 atoms are surrounded. If 4 atoms are surrounded, the hybridization is sp3, not sp. sp3, not sp. So hybridization is sp3, but geometry is linear only. Which linear? Polymeric linear. So hybridize sp3, 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 sp3. Tetrahedron structure, tetrahedron structure, tetrahedron structure. All tetrahedron structures are connected each other to form a polymeric chain. So sp3 polymeric linear structure. So answer is sp3 is correct answer, not the sp, right? So see, even though we have shortcut methods, in that we have some exceptional cases. Let's SiO2, Si is 4 group elements, 1, 2, 3, 4, 2 oxygen atoms. So 2, 1 sigma bond, another sigma bond, 2 sigma bonds plus 0 lone pair of electrons, sp hybridization, 0 lone pairs, linear geometry. But it is wrong. Why means SiO2 exists as each Si atom is connected with 4 oxygen atoms. Each Si atom is connected to 4 oxygen atoms. 4 oxygen atoms. So if it is surrounded by 4 other atoms, the hybridization is sp3. But it is polymeric structure, sheet-like polymeric structure. So sp3 hybridization and sheet-like polymeric linear structure. sp3 sheet-like polymeric structure. Sheet-like polymeric structure. Right? So like this we have some exceptional cases also. Thank you for watching.